All right, what's going on? I've heard that I have mic issues, so I'm going to hold the mic like this and then put it back to where I usually have it when I'm coding. So there will probably still be some mic issues. We're doing lead code. I had an idea. I actually have an interview coming up. So I'm going to just take the blind 75, only do the mediums, which isn't 75, is like 1, 2, 3, 4, 5, 6, 10, let's say 20, 30, 40. It's like 40 questions. Let's just count how many mediums are on the page. Yeah, it's like 49 questions. Okay, it's kind of a lot. Whatever. We're going to do all those. All right, container with the most water. We were given an integer of a height of length. Okay, so seems like a two-pointers problem. I think you start one here, you start one here. Now, how do the pointers move? Well, I started at 1 and I started at 7. Obviously, I want to move 1 because the 1 in front of it is larger. Oh, but we just want the highest volume, right? Okay, so why did we move this? Well, because it's larger. We didn't move this because it's smaller. Well, either way, we want this to match this. So even if this was like, even if the next one was really small, you would still want to move it anyway because eventually we want to match this as best we can. With okay, I think I got it. P1 0, P2 pointer 2 is equal to length of height minus 1. And now we're going to go until is less than P2. And now we need to have our current max. Cur equals. So now it's going to be the maximum of our current maximum and the minimum of height P1, height P2, right? Times P2 minus P1. That is this square. It's the minimum of these two, right? Times this index minus this index. Perfect. If height at P1 is less than height at P2, then we want to move P1, else we want to move P2. At the end, we'll return our current largest maximum. List index out of range. Why? Oh, P2 minus equals. Nice. No way. I actually just demolished this question. Oh my goodness. Maybe I'm improving. All right, next. I am very intentionally skipping. I'm trying to look at stuff that looks interesting. Okay, binary tree. I haven't done a tree problem yet. Given the root of a binary tree, return the level order traversal. 3, 9, 20. Oh. This is going to be embarrassing. Okay, this is a breath for a search. Right? And then so we have our array here. Let's pump out the Microsoft Paint. And let's pump out the snipping tool. All right, so we have this tree. Now what do we want to do? Well, we want to do a BFS and a BFS uses a queue, And for each level, we want to get all the nodes in that level. So first, okay, so BFS, add the current node. Okay, now at its left, right, at its left, at its right. Oh, so we need to sort of have two queues. So we have this one here, right? And now this one here is going to say, okay, pop this, add all of its children. Okay, pop this. Pop this, add all of its children. Pop this, add all of its children. Whatever here, null, null. Pop this, add all of its children, 15, 7. Interesting. So there's two arrays going on. And then every time we pop and add the children, we append it to our final array. Okay. Okay. So we take our 3, start with 3, right? And then maybe while this is not empty, pop, right? We initialize an array, pop it, and then we add its children to what? We add its children to here. Okay, now we have 9, 20. While this is not empty, okay, so we iterate through this, right? Iterate through that. Add all of these to an array. And then add their children here. So pop this, add the children, null, null, pop this, add the children, 15. Okay, I'm sort of getting it. I'm sort of piecing it together. Okay. So that's our final answer. Iter I equals root while I is not none. Sorry. While length of I is greater than 0. For n in I, we want to array, okay, level. We're going to append n to the level. And then we're going to append I.append n.left, I.append n.right, and then at the very end, array.append level. Oh my God. Jeez. Oh, I see. There's a node and then there's the value. Okay. Level.append. Level.append n.val. I.append if n.left, else none. If n dot Okay, let's do this. If it exists, then we do all this. If n doesn't exist, oh, we're not even popping from I. Hold on. This is, yeah. Okay. Oh, hang on. We can just pop it at the end. Yeah, we're not even, we have to remove it from I once we're done. Okay. All right. Mm-hmm. Okay. All right, let's start from the beginning. Right. We have our paint. Okay. Our array is empty. Our I is the node 3. I say node 3. Okay, while length of I is greater than 0. Okay, level is empty. For n and I, if n, level dot append n dot val. And then I dot append n dot left, so node 9. Okay, so we actually want to pop from I here. Okay, sweet. So now this is gone. And now we finished looping through. Oh, hang on. We need 2 different arrays. Because we're appending to the same. Oh. We're going to do this at the end. If n, level dot append n dot val, okay, 3. Else, level dot append none. Perfect. Now where do we want to add the left and right? I think these variable names are kind of confusing me here. Yeah, it's dynamically. Okay, hang on. First of all, let's do this. And let's do length equals length of n before this, and then for I in range, length. So that's fixed. If n at I, level dot append, n at I dot val, pop it, and then we append n at I dot left, append n dot I dot right, none, and then at the end of the loop, and then this is all n. Come on. What is going on, dude? Okay. All right. N array. Start with the root. So node 3. Here's level. And then the length is the length of n. 1. So for I in range 1, we do this one time. If n at 0, yes. Level dot append n at 0 dot value. Pop it. Oh my god, I'm actually an idiot, bro. Oh, I'm actually an idiot, bro. Or do I pop at the end? I do have to pop at the end. Yep. This is quite embarrassing. Okay. For I in, length equals 1 for I in range 1. If n at I, yes. Add it. N dot append n at I dot left. So node 9. This. And then we pop it. Sweet. Oh. Okay, pop. Now array dot append level. Perfect. Now we have 3. Now while the length of n is greater than 0, yes, level is now blank. For I in length equals length of n. 2. Perfect. 2. So 0, 1. If n at 0, yes, level dot append, n and I dot value. Now n dot append, the left, which is none, the right, which is none. And now pop 0. Okay, so that was the 0th iteration. Now the first iteration, n 20, if n at 1, yes. Add to the value. Add 15. Add 7. Pop this. Now we finish iteration. Add 920. I'm not seeing. Okay, now we're at none. For I and length equals length of n. 4. Okay. So 0, 1, 3. I don't see. I really don't see what's going on here. I really don't see what's going on here. It should be 0. And then 0, 1. And then 0, 1. Why is n at 2 out of range? Oh, is it because we're popping it? Oh, we don't even append none? Oh, we don't even append none. Oh, major blunder. Okay, we don't need to print I anymore. Okay. Okay. Dude, please work. Oh my god. Oh, right up pop -1. Alright. What's the non-stupid way of doing this? I didn't use a Q. Why didn't I? Is this really just BFS? Are they really just going to show me BFS? I literally said BFS and then I didn't do anything. Collections.deck. I mean, other than other than that part, I feel like this is pretty much the same thing, huh? Yeah, I should say node equals and not pop 0. Then add the value to the level. Yeah, this is really just a BFS traversal. I need to really just memorize that. All right, I'm gonna practice writing this without. All right, we're gonna speed run BFS traversal. While n, this is a BFS traversal. This is our node. Level dot append node. Node dot left. Dot append node dot left. Node dot right. Dot append node. Yeah, this is really just a simple. Oh, come on. This is just a binary search, bro. This is just a binary search. I mean, binary breadth. What am I saying? Breadth first, breadth traversal. Breadth first, breadth, right? Breadth first search, breadth first traversal. Sorry, I'm not having a good time right now. All right, fundamentals. Fundamentals. What? What? Hello? What? This is the same thing. Let's ask GPT why. Oh, I see. If root is none, if not root, return. Oh, is it really just this line up here? Ah, I see, I see, I see. I see. All right. So, breadth first traversal. you're using a Q. So you add it to one end, remove from one end, start with the root. Add the root to the Q. While the Q is not empty, pop it, add it to your level, and then add the left and right to the Q. Simple, man. All right, cool. How long is this video right now? 30 minutes. All right, cool. 2 problems, 30 minutes. Second problem, embarrassingly long. Getting better at breadth first traversal. Thanks for watching.